I'm Johanna Ladella.
Lizzie Patel.
Shonice,
and this is the extra credit assignment for Howard's Doppler effect. We will now be demonstrating the Doppler effect. You will see a car approach the camera at high speed honking. Make sure to notice the change in frequency.
The Doppler effect occurs for all kinds of waves. It happens when either the source of the waves or the receiver of the waves is moving. As the car moves away, the sound waves get spread out and you hear a lower sound. As the car moves closer, sound waves get less spread out and you hear a higher sound or pitch.
The Doppler effect occurs when a person is standing somewhere and the sound of something is coming towards the person hears it at a higher pitch. This is because as the wave travels towards where the direction of the person is, the particles that the waves are pushing hits the person much faster. And then, when the sound is traveling away from the person perceives this as a lower pitch and at a lower volume as the distance increases because the particles are still moving in the direction the wave is traveling. Therefore, the particles do not hit the person's ear as it did so when the sound was traveling to the person at a much higher rate.
Observe the change in frequency that occurs as a result of the particles of sound moving closer and closer together as the car approaches the camera. One can observe this in the change in sound.
Now listen for the change in sound as the car goes past.
Prisms are objects that disperse white light or sunlight through the material. The prism can be glass or water droplet, etc. The white light enters the prism and is refracted. It is totally internally reflected, and then refracted once more. Depending on the wavelength of the light within the visible spectrum, light bends at different angles and appears at different locations after it has been refracted from the prism. For example, red light has a greater wavelength than violet light. As a result, it bends less, and thus it is seen as the topmost arc in a rainbow. When looking at rainbows, for example, those occurring in nature, one may notice the specific arc of the colors of the visible spectrum. Visible light that is refracted from a prism forms specific angles with the angle of incidence of the white light. For example, red light forms an angle of 42 degrees, while violet light forms an angle of 40 degrees. The colors in between the visible spectrum of red and violet form some angle between these two angles. We'll now be recording rainbows created through prisms with these lights.
A rainbow.
Rainbows!
I can
Rainbows everywhere.
Try again.
Point to it then.
It's right here.
Oh yeah, there's the violet and the red.
In the dark.
And there's one over in this corner. Actually, there's two. There's three! Well, as you can see, there's a lot of total internal reflection going on. Yep, we'll talk about that. Yep, and Shonice is really excited. So, those are the prisms. Yay! There's Lizzie and me. In describing a prism, one must understand how the dispersion of light affects what is seen at the opposite end of the prism. Dispersion is a phenomena that bends light at different angles as it moves through a refracting material, such as a prism. When the wavelength of light increases, the index of refraction decreases. For example, blue light, which has a wavelength of 470 nanometers, compared to red light, which has a wavelength of 650 nanometers, Blue light is bent more than red light. When white light or sunlight entering a prism is dispersed, the blue component of the incoming ray is bent at a greater angle than the red component, and so the rays that emerge fan out in a series of colors in the visible spectrum. The order of the colors is red, orange, yellow, green, indigo, and violet. In nature, dispersion can be seen through the phenomena of rainbows, and thus a rainbow is created.